Hi folks, we are Group 20 and we are here to present our group's work through a YouTube video. So now first let me introduce our group member. We have, I'm Terrence, we have Harry, Kevin, Anson, and Eunice. So first of all, let me introduce about the architecture of our project. It's quite simple and agile. Our user will request the HTTP through the port 3000 through our instance AP address. This instance will contain both frontend and backend. And frontend and backend is built by Docker file in different containers and a Docker compose will one-click deploy both front-end and back-end's image and run them simultaneously. The front end will request data from backend through a RESTful API, and the backend will request from the CouchDB instances. We have two main instances. One of them will store the data from Twitter, also will contain the data from ADO. The other one is the data from Mastodon. We will harvest data from Mastodon, and the harvester is also one-click deploy by Ansible playbook. We can deploy the harvesters and the instances locally in localhost. So now let's introduce Harry to present about the implementation parts.
So now I will introduce some implementation details of our system. First is a Mastodon harvest. First of all, a raw copy of data will be harvested and stored into the CouchDB. We use multiple Mastodon server, for example, AU or AU Social. After the data has been harvested, we will use APIs from Hugging Face Transformer library to perform some natural language processing task. The model we used called Twitter Robota-based sentiment. So this is a community trained model and is well tuned for sentiment classification task. By this approach, we ensure the quality and accuracy of our data. And the processed data will also be stored into CouchDB for later use for the web application. So how do we deploy the Mastodon harvester? We use Ansible. It will be automatically deployed to one of the instances on MRC. And we can also auto scale up or scale down the Mastodon harvester by only calling one shell script. So down in the image here, by the auto scale up shell script. The usage is if you supply a new IP address from a node from MRC, it will auto deploy the Mastodon harvester onto that instance. And if you use the existing options, it will deploy the Mastodon harvester to existing instance on MRC. Let me illustrate in details on how we leverage Ansible as an automation tool in our web application system. As a powerful IT automation tool, it allows us to manage complex deployment and scaling process effectively, especially in our case, where we interact with instance on MRC, Melbourne Research Cloud. So first, let's take a look of our one-click auto-deployment file. This is our one-click auto-deploy Ansible playbook, which is designed meticulously. It is segmented into 3 sections, focusing on 3 specific tasks. Each operates on a set of hosts categorized by their roles. Firstly, all instances go through this process, which is the environment initialization. We set up the dependencies and clone the Git repo. This means every instance will have the necessary dependency installed and appropriate repo cloned. Some packages may include apt, git, Python, or Docker. You can find the details in the roles directory here. In this file, we install dependency for different packages, for example, apt, git, Python, and Docker. This is the file to clone the Git repo. The second task is to set up Mastodon harvester executed on host assigned to it in the inventory file. In the inventory file, we separate different instances to their different roles. This allows us to manage different instances respectively. The role run Mastodon harvester initiates the Mastodon harvester on this host, providing a seamless flow to store raw data or processed data into CouchDB. Now let's take a look of run Mastodon harvester. It evokes Python files to perform data analysis and data harvest. In the last section, we set up the web application on host labeled web app. This involves deploying both the front end and back end of the application using Docker containers and setting up necessary environment variables. In the role of run web app, we simply call the command docker compose to deploy both front end and back end. An essential feature for our system is the auto scalability. Given the varying demand, we have made it possible to scale the Mastodon harvester both up and down. This can easily be adapted for large-scale application by integrating demand listening. By running this auto-scale-up YAML file, we can auto-scale up a Mastodon harvester on a new instance. Now, let's do a quick demo. Suppose we want to scale up the Mastodon harvester. Here is a detailed README file for you to follow the procedure. As you can see here, by following these steps, you can auto-deploy and auto-scale up. Now, let me do a quick demo of how do you run the shell script. First, open up our terminal and cd into the Ansible directory, and then run this command. This command is for you to change the mode of the shell script to executable. After this, we can run this command. As you can see, this command did not execute successfully because we need to either supply a new IP options or existing IP options. In this demonstration, I will just use the existing IP to scale up the harvester. The existing IP is listed here, called temp harvester. This is a blank, new, empty MRC instance for us to scale up the service. Okay, the process has complete. As you can see, we successfully auto-scale up our Mastodon harvester. Auto-scaling down at meantime is just as simple as auto-scaling up. You can just run the auto-scale down script over here. While our system is robust, there are some challenges. For example, managing the volumes and CouchDB. Here we have a script to automatically map the CouchDB to the volume that attached to the instance. This allows us to have a data backup. Despite the challenges, our system design and utilize Ansible ensures efficient, consistent, and reusable operations, offering an effective solution for auto-deployment and scaling processes. The well-structured Ansible directory and playbook further contribute to the manageability and clarity of the project component. In the next section, we'll have Anson to talk about our project scenarios.
As for the scenarios, we mainly focus on sentiment analysis. We care about how many positive, negative, or neutral tweets there are, and what the portion of them is in different settings. To be specific, we will talk about food, traffic, and sport of Australian life. The data we use mainly comes from three parts. From ADO, we exploit the content of tweets in English with geo-information. From pseudo, the SA4 level data such as income and population are used to explore any potential interesting findings for each topic. From Mastodon, we gather the tools from particular servers and process them for the comparison between tweets and tools. The process of the data can be concluded by those four aspects. The first one is the location classification by bounding boxes and polygons. The second one is NLP preprocess of text and keywords matching. And the third one is the LDA topic modeling. And the last one is the sentiment analysis by a BERT model. When it comes to specific topics, generally, we discover the number of tweets related to those topics, the distribution of sentiment, and the topics modeling by LDA. More specifically, we want to observe any underlying relationships between tweets and particular features from pseudo. To extend our analysis by the data from Mastodon, we want to see which topics will be discussed more and whether there is difference between the distributions of sentiment between data from Twitter and Mastodon. In the next session, Eunice will introduce the web application.
So now, welcome to our homepage. Here we present the overall data we analyze. We have about 3 million tweets that have location, and we will be focusing on 2.5 million of them that are in English. So on the right-hand side of the tutorial, we have a sentiment analysis of all these tweets. Tweets with positive sentiments has a greater proportion than negative ones. Since this is a very large amount of data, we mainly applied what we have learned in this course, the parallel computing technique, to improve the efficiency. So the processing times improve from a few days to a few hours. Now let's come to our first scenario, the topic food. So among all the 2.5 million tweets, there are about 6% that mentioned food. And here is an overall sentiment analysis of these food-related topics. And we can roughly get an idea that when people post tweets about food, they are more likely to be happy. The next session is the word cloud. Again, we apply another technique we have learned from this course, the LDA topic modeling by PySpark, to analyze all the tweets that mentioned food. We group all the keywords into 5 topics, and luckily we find some association. So for example, for the first topic here, the most frequent keywords are cake, coconut, bread, lemon, and so on and so forth. So this topic leads us to guess the topic is more likely to be afternoon tea or brunch. Now let's go to have a look at the second topic, which has the most frequent keywords crawfish, monkfish, and redfish. So we guess the topic is about seafood. A similar pattern can also be indicated for the rest of the topics. So now let's move to our third part, which is the map. We have 2 maps here. The area is divided by SA4, the statistical area level 4. So there are about 90 polygons in our map. The left map here shows the frequency of the post. So from the color, we can see that here, let's zoom into Melbourne. We can see that from Melbourne, this place called Inner South, they have the highest number, relatively very high number of post frequency. So the number here means that for every 1,000 people, there will be about 92 tweets that mention food in Inner South Melbourne. So by looking at the location, this area is where St Kilda locates, our favorite vacation place. So we guess people who post in St Kilda are most likely for vacation, and a large topic for vacation is actually food. So the same finding can also be shown in Geelong here, where the Great Ocean Road starts. So Geelong also has a higher proportion of tweets frequency about food. However, we expected inner city to have a large number of tweets, but this is actually not true. So this might be because people are busy in big city to post their food. The second map here presents our selected features, the income. So the area with higher weekly personal income will have a darker color. However, in compared to our tweets frequency map, we couldn't see a similar pattern of color. So it doesn't seem like income will affect people's attitude towards food. The final session, we list out the top 10 areas that have the most positive attitudes toward food. We can see that Brisbane's West is the one that's most happy about their food here. And in general, all the top 10 areas are large cities, so people in large cities are more happy about their food, might because they have more food choices. Another bar plot here shows the top 10 areas that post food most frequently, and the top 5 are still the big cities. The final plot is the top 10 area with highest income. The area really doesn't differ a lot, so this also explains why we couldn't find a correlation between people's attitude towards food and income. Now let's move on our second scenario, vehicle. The structure is basically the same, so I will discuss them in short. So overall, there are about 3.2% of tweets that have mentioned vehicles, with positive tweets having a greater proportion. Here is again a topic modeling for vehicle, so we might find some interesting pattern and interesting topic from them. Now the map here on the left as well, it shows the frequency of tweets about vehicle again, and the map here shows the average number of motor vehicles per household, the average vehicle counts per dwelling for each area. We can see that in general, the area next to the coastline has a darker color. This finding matches Australia's overall demography, where the coastline area is developing better. We then try to explore the relationship between people's attitude towards vehicle and the number of vehicles they own. So one interesting finding is that this place called Sydney, Balkenham Hills, has the most negative sentiment towards vehicle. But on average, the number of motor vehicles for each household in this area is actually the highest. We plot a scatter plot for these two features. So this place in Sydney, it corresponds to this point, the most lower right corner points here. By examining this scatter plot, we can see that although the correlation is not high with majority of points clustered in here, there is still an approximately negative relationship between the two features. So a possible reason for this is that when people have more vehicles, they are more likely to complain about the traffic. The next scenario is sport. The structure and the visualization is still very similar as before, and there are about 3% of tweets that mention sport. The distribution of sentiment is still very similar to the above two scenarios, which lead us to indicate that when people post a topic about their daily life, they are more likely to post positive things to make themselves have a good social portraits. And now I will let Kevin to discuss our Mastodon.
So the top graph right here is about the total topic distribution of Mastodon data. For example, right now, the total number of tweets for food is sitting at 80,141. And if I refresh this page in a second, this value will increase. This is because we are gathering data from our backend with the RESTful API, and this data is being analyzed and streamed real time from the Mastodon harvesters. The 6 graphs below are about a comparison between the general trend of Mastodon data and Twitter data. On the top, we can see that generally people are expressing themselves neutrally on Mastodon. And on the bottom, most people on Twitter tends to post positive things. The proportion of positive tweets is way more than those tweets in Mastodon. And there's more positive tweets than negative tweets in Twitter, but there's more negative tweets than positive tweets on Mastodon. That's the end of the presentation. Thank you.